All right, folks, let's get started. Thank you for coming to this session, CI/CD pipelines for infrastructure automation. My name is Adrian Iliesiu. I'm a senior developer advocate with Cisco DevNet. And for learning at Cisco, back in the days when we were, we're still collaborating, but we were part of learning at Cisco at some point. So I ended up being one of the co-authors of the DevNet Associate official cert guide. So if you enjoyed that book, then I wrote most of the chapters in that book. If you don't, then I didn't. So hopefully you guys found that useful. We're coming with the second edition. If anyone is interested in the Devon Associate exam, so there's going to be a new book coming up in the new year. So hopefully you folks find that useful. Besides that, I cover everything enterprise networking from Cisco from a developer perspective. So I cover, well, not everything, but most of the Catalyst Center, iOS XC, Meraki, and then Catalyst SD-WAN. So if you have any questions as you develop, interact with the APIs of any of these products, let me know. You can find me on X at that, and also I'm on LinkedIn. Drop a message. Let's connect. If you have any questions, I believe there's also a WebEx team space for this session. WebEx teams, just drop a message in there. And I'm more than happy to help you. So for today, we're going to talk about CI/CD pipelines. If you stick to the end, there's an Amazon Echo here that you get a chance to win. There's a raffle going on. So yeah, there's one extra incentive for you to kind of stay to the end. And hopefully the content will be useful too. Okay, so the agenda, will quickly go over a CI/CD overview. Right, so what is CI/CD? What we understand by that? We'll have a look at GitLab. A quick one slide there for a CI/CD pipeline workflow, how it would look, a whole CI/CD pipeline in an infrastructure automation world. I'll have a quick demo, and then we'll wrap up with resources at the end with some useful links for all of you. All right, so how many of you have heard of CI/CD pipelines first? You have heard, yes. I mean, there's a bunch of sessions here, right? CI/CD pipelines everywhere. All right. How many of you are using CI/CD pipelines day to day? All right. All right. Okay. So let's level set first. CI/CD overview, right? What is CI/CD for folks that are just new to this? You can think of these pipelines, and they've been used in the software development world, right, for 10, 15 years now. And how can we kind of adapt these set of tools, I would call them, for our own environments as network engineers, infrastructure people? How can we kind of adapt these pipelines for our own purposes? So the CI in the CI/CD usually stands for continuous integration, and this is like your basic step as you build your pipelines. That's just gathering code from software developers in one central location. So you have your version control systems, usually you have your GitHub or your GitLabs or whatever else you're using. And as you developers write applications, they write the code every day or at lunchtime, whatever the time is, they would just do a git push to a central location. They would just gather all the code in that place, right? So that's similar to kind of what we do as network people. We still deal with text files configuration for devices, right? So it's similar. They have text files with source code. We have kind of similar text files, but with configuration files for all these devices that we're managing. So that's the continuous integration. As you go to the next level, you have the code, right? You have your configurations in one place. From a software development perspective, what they do next is they kind of start testing that code, right? So they've developed a new feature. They kind of they're building automation to test the code and make sure that the features that they've written are working as they're expecting them to do, right? So that means that you can create releases at this stage. So that means taking your Java application and creating a jar file, right? So a jar executable, or creating a binary file. Or if it's a Python application, you would have maybe like a Docker would be created at this stage and spun up, and you run the application in that environment. So similar to what we do right at this stage, we kind of also would be nice if we can test our changes that we're trying to push to our infrastructure, kind of like in a test environment. So we'll have a look in the demo at how you can do that. So all tasks are automated, right? And you would run additional tests and checks at this stage. So if you want to take it a step further, right? You gather the code in one location, you build your release, you tested the feature. Now the next stage would be a continuous deployment in this pipeline, in which you automatically deploy your application to like a production environment, right? So using these pipelines, big corporations like your Amazons of the world, Metas, Googles, that's how they push changes into their application using these pipelines, so they can push hundreds of changes per day, right? With these automated pipelines. So the deployment takes it to a production environment. You have tested, you have built your release, you have your binary, you're deploying it in a stage environment, you're testing it there, all automated. And if all the tests pass, then you can automatically push it to production environment, right? And have it from the developer writing and developing the feature all the way to production, all automated. So now, using these pipelines for infrastructure automation, you would have your configuration changes done through automation. Something like an Ansible playbook, right, or Terraform could help you in this. Have it integrated as part of your pipeline. You get a historical insight into the changes, so you can have a version control of all your configuration files, right? You create a new VLAN, or you configure a new trunk, whatever it is. It keeps track of all those changes that can easily revert back to a previous version, right? So you configure something that caused an issue, right? You can just revert to the previous version. You can validate changes. So you could have, I'll show you a CML environment, so Cisco Modeling Labs, where you could have a subset of your infrastructure, of your network, in which you test your changes, making sure that they don't introduce any faults or any breaks into your network. And then if you want to take it to a full continuous deployment, you can have your pipeline integrated with ticketing systems like ServiceNow, right? You can have it with Splunk integrations, right? So you could have the change has been done by your infrastructure engineer. They do a git push. It goes to a central location, triggers the CML test in the lab environment, right? And that goes and creates a ServiceNow ticket. Then goes back to a manager. There's like, yes, I want to approve this to go to a production environment. So you can have all those types of integrations as part of your pipelines. All right, so that's what I had for just an overview of CI/CD and how to use it for infrastructure automation. Let's have a look now at GitLab. Any folks familiar with GitLab that have used it? Yes. Oh, just a couple. All right. So I'm a big fan of GitLab, actually. And besides of course, the hosted Git repository that it has, it's a version control. Originally, it was a version control solution, right, used by developers. But then they kept adding features. So now it's got to a point where it is a complete DevOps platform. And for the purposes of our discussion today, they have a built-in CI/CD pipeline component to it, right? So it comes with it out of the box, pretty much. You can do project management, right? You can keep track of issues. You can keep track of all the branches and all of that. So the pipeline component looks like this, right? So you can build, you see here a pipeline with 6 stages. This one is just with 1. And they're at different, so this one is still running, right? The last stage of the pipeline. Second stage, you have some warnings in there. So you can build pipelines, right? The first stage, for example, would be, just running initial tests, gathering all the configuration in one location, and you make sure that it's just initial test where there's no spaces or you're not commas or anything like that. Stage 2 could be, reaching out to an Ansible playbook to configure a CML instance, right? And then based on the output that you get from there, you create in stage 3 that ServiceNow ticket, right? If it passes stage 2, that it creates a ServiceNow ticket. Stage 4 would be, okay, somebody has to reply to that and approve, or you can have automatically approve the ServiceNow ticket in stage 4. And then stage 5 could be, deploying it to a production environment. So this is all, these stages, it's really up to you how you create them and how you define them. So the pipelines are composed of jobs and stages. So the job is what it should do right at that stage. And then the stage is actually when to run the jobs. So they're running one at a time usually, right? So you start with the first stage, and as it progresses, it does a certain function and then moves to the second stage. And basically, if something happens at any of the stages that you get an error or you cannot go through, then that run of the pipeline has failed. Basically, I need to go and investigate what happened. So a typical pipeline in the software world would be, the build stage, where you compile the code, then you do your unit tests in the second stage. Third stage will be a staging. You run your application in a staging environment, make sure that it works. And then stage 4 would be deploying to production, right? So we can have something very similar in our worlds. In GitLab, there's also the concept of runners. And these are just processes that are used to run the jobs, right? So when you install GitLab, the GitLab runner is a separate process that you need to install. And basically, a pipeline is triggered as you do git clone, and the repo then executes the instructions inside of that gitlab-ci.yml. So that file is very important, that YAML file, because that's where you define your pipeline, all the stages. And I'll show you in the demo how that looks. And we'll also see in the next slide a possible example of that. So implements a variety of executors. You can have the pipeline at each stage, connect with SSH devices. You can run shell scripts. You can start parallels instances, VirtualBox. You can have, I want to deploy as part of my stage a virtual machine. And then I want to have Ansible install whatever on it. Then the next stage would be, okay, I'm building now a Docker container, right? And Kubernetes, you can have it integrated with, or you can create your own custom jobs as part of this pipeline. So that YAML file that I was telling you about, right, looks similar to this. So you have your stages at the top, and then the image, which is basically in this case, it's a Docker image. Alpine is a very stripped down version of Linux. So that's where you would have your tool pre-installed, right? And we'll see in the demo what I mean by that. So then you define your stages. It could be, as simple as just echoing back a script, yes, everything is okay. Or it could be SSHing to a device, right? Or whatever your use case may be. So an example of a CI/CD pipeline in the wild, or how people actually do these pipelines, and you've seen, this really depends on you. There's a lot of tools out there, right? So it's like mix and match. This is just one example using Jenkins and GitLab. And I have here an APIC example for an ACI environment, right? But in our demo, we'll have an NXOS setup. So you have your network engineer there, right? On the left-hand side, submits a change, goes to GitLab, that triggers a webhook to Jenkins. Jenkins, in this case, is like your build server. Jenkins takes that change that the network engineer has performed, goes and using Ansible Tower, has a simulated SDN, basically a copy.
A1, 2, 3, 4. A1, 2, 3, 4. A1, 2, 2, 2. A, 1, 2, 3, 4.
Okay. Somebody took over here. All right, so you have a copy of your API controller, right, where you would run your tests, making sure that the changes you're performing are not breaking anything. Then from your simulated API controller, you go back to Jenkins.
Yeah, cool. No worries. 1, 2, 3, 4. 1, 2, 2, 2. 1, 2, 3, 4. Okay, that.
So Jenkins would see if everything went well, right, in your simulated environment. Then it would go and run a production Ansible tower and would actually perform the change in your production API controller, right? So that's one example. Like I said, you could have all types. Jenkins could be replaced by Drone.io or even GitLab itself. There's other build servers. You could have GitLab replaced with GitHub, many different combinations. You could have here, if you're a Terraform shop, right? You're not using Ansible, you're using Terraform. You could replace this with Terraform completely. All right, so that's an example of a pipeline, how it would look. Now let's have a look at a demo environment. So all the components in the demo that you see, so I have just a Mac laptop as a dev workstation. That would be basically the network person that's performing a change, right? The hosting server, it's a CentOS box, and that's just running GitLab and the GitLab runner. I'm using CML for my simulation, right? So I have a subset of a production network. I'll show you how it looks, the topology. So I'm performing the changes in my CML, right? Making sure that they're not introducing any breaking changes. And then all the changes I'm doing them with Ansible. So I have Ansible playbooks. GitLab is the source control and also the CI/CD component. And then I'm using pyATS as my testing framework because I want to take snapshots of my infrastructure, right? I'm taking a snapshot before I do any changes, making sure that my OSPF neighbors are there, right? Making sure that all the routes are part of the routing table. And then I'm performing the change. And then I'm taking another snapshot, making sure that whatever I've done has actually been applied. So in our example, I'm just adding one more OSPF route. And I want to make sure that an OSPF route has been propagated throughout all the infrastructure, right? And all the neighbors have gotten that new route. So I'm taking another snapshot with pyATS and making sure that that route is, as expected. So this is the topology, how it looks, right? It's a fairly simple, just 2 distribution routers and 2 distribution switches. So we're going to perform changes on these devices, right? We're going to add one more loopback interface that we're going to propagate over OSPF on both of these switches as part of our pipeline. So I have a video recording of this because the session is only half an hour and they don't really want to go live with it. But the recording captures pretty much everything. So you have your 2 devices, NXOS switches, right? Nexus 9000 Vs. They already have a configuration. OSPF is already configured on all the devices. Routing is working as expected, right? Everything is propagated. And this is my GitLab. Oh, sorry. And that's my GitLab environment, right? So this is running on CentOS. And I just have a installation of GitLab on there, Community Edition, which is free, right? And it has all these files in a repo that I'm calling CI/CD. All right, so I'm having the actions folder in there, config, group vars, host vars, pyATS. This will have all the pyATS components. And more importantly, I have that gitlab-ci.yml file that I was telling you about where you define the stages of your pipeline. Right, so this would be your regular Ansible group vars, host vars when I'm defining, right, variables for my group of devices or for each individual host. Config and actions contain just the Ansible playbooks that I'm going to run. And let's play. And let's have a look at that gitlab-ci.yml and see how it looks. All right, there we go. So I have 3 stages as part of my pipeline, and this is how I define them. Fairly straightforward, right? And the image that I'm using, this is getting taken, is basically downloaded from Docker Hub, or it could be from wherever you want it. You want it to point it to a different location on an HTTP server somewhere. But this is a Docker image that I've built that has already pyATS pre-installed, has Ansible pre-installed on it, right? So it has all the pre-required tools that I'm going to run as part of my pipeline. So the 3 stages: the pre-snapshot with pyATS, then I'm deploying OSPF with Ansible, and then I'm taking a post-snapshot also with pyATS, making sure that the changes that I've done with Ansible at stage 2, right, the new route has been propagated and is in my network as expected. So then once you have defined, well, this is just instantiating, starting your stages, then you have to define at each stage what you want the stage to do. Right, so I'm running a script, I'm changing directory into the pyATS folder, right, and then I'm running a pyATS job that takes these parameters, which is just how pyATS works, right? A regular pyATS run. I'm saving the artifacts, so whatever pyATS returns to me as part of the in this location, pyATS folder, pre-snapshots, and I'm saving them as JSON files. Deploying SPF, I'm running an Ansible playbook from this location, so it's actions folder, configure SPF, configure SPF.yml, which is just your typical regular Ansible playbook. And then post snapshot, same thing. I'm changing the directory into pyATS folder, pyATS run the job from that location with this CML test lab environment and trigger data files. This is important because you're telling pyATS what to look for, right? That's where you specify, hey, this is a new route. I want you to make sure that that new route is part of the change that has been propagated, right? So that's where kind of the magic happens. So we're saving the artifacts again, right? So whatever output you get from pyATS, you save it in that folder, and you can do diffs after that, right, between pre and post snapshot, and see what has changed. All right, so that's GitLab. Let's check now. So I have that same repo, right, clone on that Mac machine. I have my host vars, the 2 switches that I was telling you about, right, and this is their OSPF configuration. So they already have several interfaces enabled for SPF. I'm going to add one more, a loopback 101 on both switches. So that 177 and 178. Same thing on the second switch. And you could have anything, right? I'm just showing our SPF. You could have BGP. You could have a whole configuration of the device from scratch. This is just an example to show you how it works. So switch 2, we see here, there's no loopback 101 before we apply the change, right, on both devices. Switch 1, this is just the loopback 100. So I've performed the updates in my YAML file, right? I checked that the loopback 101 is not on any of these devices. OSPF is working as expected. All the routes, all the neighborships have been established between all these devices. So by simply saving these files, and let's have a look at the post. I'm saving them. And the post trigger data file that I was telling you, that's in the important component in pyATS, here is where you tell pyATS what to look for, right? So I'm doing a show IP route with pyATS, and I'm telling you, look for the new interface, the 101.2 on switch 1, right? So I want to make sure that it's being advertised, basically the route from switch 2, it's on switch 1, and the new route from switch that's being added to switch 1 is also learned on switch 2. So you have the 3 files that have been changed. You do a git commit. And this basically triggers the pipeline, right? Git commit, git push. This goes and pushes back the changes to that GitLab location that is running the pipeline. So you authenticate with your credentials. Okay, the push has been done. And now you go back to GitLab under pipelines. And like I said, the pipeline has been automatically triggered. The three stages that we're talking about, right? The pre-snapshot with pyATS is right here, the deploying your SPF with Ansible, and then post-snapshot with pyATS. So if you click on it, right, it's pretty verbose. It's getting that image from Docker Hub. If it's not already there, the image already has the Docker image, Ansible, right, pyATS. Then it runs the pyATS within that Docker container itself. So you see it completed. It took a snapshot, right? It runs stripe your routes, stripe your SPF neighbors, right? Everything that you want to take a snapshot, an operational snapshot, right? You want to make sure that you have the right amount of neighbors. So stage one has been completed successfully, goes to the next one, which is deploying your SPF, in which is going to run that Ansible playbook, right, from that actions location. And the Ansible playbook is going to configure those two new interfaces for SPF. And this is taking a bit. So once it's done with this, right, you see the output. If everything went well, you get a green check mark. Yes, the stage has completed successfully, or not. If it ran into any issues, then it fails. Then you go and you have to investigate what happened. But since we have a video recording, we know that this is going to work. And then stage 3, right, there's two new loopbacks, loopback 101, everything went well, job has been successfully completed. So then it's going to the next stage, stage 3, and it takes another snapshot, and in that snapshot, make sure that these loopback interfaces have been learned between the devices, right? There you go, stage 3. So now next, right, this is all in a test environment. You could have stage 4 deployed to production, right? Or you could have this as part of a test branch in GitLab. And when you merge this into your master branch, that triggers the pipeline that will go and do the production deployment. So you can also have different branches. You can control your pipeline that way too. Okay, so you see loopback 101 now is on both switches. It's configured. I made sure that pyATS, right, the routes have been learned. And that's how you run a pipeline with 3 stages, configuring your OSPF in this example on a couple of NXOS switches. So you see the routes have been learned and propagated, right? The 101.2 learn over all those interfaces, and same thing on switch 2, show up your auto SPF. You see the 101.1. This is just double checking on the CLI. Trust but verify. All right, so pipelines you see now all successfully completed, like all 3 stages, right? Passed. The nice thing is that you get all those artifacts, right? From pyATS, it has saved all those JSON files. You have a historical overview of everything that happened as part of the pipeline. It's very verbose, right? Or is as verbose as you want it to be. But it gathers basically all the data possible, both operational, right? And that's what you want, because with Ansible, as you check, it doesn't necessarily check operational data, right? So OSPF neighbors that are there or not. It just configures OSPF for you. It's done. But has the route been propagated? Is the neighbor actually has learned the route? Is it actually working? So that you don't really have with Ansible tools like this, but that's where pyATS comes into the picture. So resources for you folks, I have actually a whole playlist, 12 hours of video content right here to set up this from scratch, right? So it's basically how you install CentOS, how you install GitLab on that, how you have the runner, how you build your Docker container, how you get your Docker container on Docker Hub, how you install Ansible, right? Every single step, 12 hours of video content on that YouTube playlist. There's more stuff in there. Also, blogs.cisco.com. I'm writing blogs on how to do this. I have 4 blogs already walking you, step by step, written blogs on how to get this done also from scratch. Think that's it. We're right on time. Any questions? I can show you the playlist here at the bottom. Introduction to CSD pipelines, then finishing up the Docker Compose, setting up VS Code, lab setup with CML, CML licensing. So as I was doing this, right, I ran into all types of problems, NTP on CentOS, CML licensing issues. So you also see me troubleshooting those. If it happens to you, then you know how to actually come around those. All right, so then I think we're ready for the raffle, folks. Ready for the raffle? All right, so we have a Amazon Echo. Let's see who's gonna be winning this Amazon Echo. I mean, all right, so the winning raffle ticket is 346612. There you go. Congrats. All right. Thank you very much, folks. Hope you found it useful, and see you on the floor here. Hope you enjoy Cisco Live.